Some of you people have already been following the Fastfingers saga, and some of you haven't. We finally have the program ready. I finally have the program ready. This is the production interface for it. This plugs into the C64 user port. That also leaves open the cartridge slot. So depending on what I decide to do, I don't know if down the road, it's fairly complex, I don't know down the road if I'm going to, there might be enough memory on this chip to put the whole program on there and then have it uploaded to the 64. But if that's not the case, if that doesn't work, I hopefully I will have a cartridge version of the program for the people that don't want to carry around their 1541s. Okay, so this is the interface. I have one plugged in right now and running. And we have up on the screen Cubase running. Cubase is playing this will be Sweet Dreams by the Eurythmics, and it's playing into the MIDI interface, and you're hearing, and the sounds you're hearing are the Commodore 64. And thanks to my wife for getting me the MIDI file. I'm going to change the sound on the 64 using another keyboard because I'm passing through the program. So the program is a MIDI through. So it's keyboard to computer to 64. That's how it's working. So I can actually change the patches from the keyboard because the MIDI program recognizes program change and velocity change. That was an organ sound with a chord on it. All I did was cancel out the chord on the 64. Oh, that little piece. I must have edited that little piece on that little. So I'm not doing much more on that. I just wanted you to hear what it could do if somebody could actually play an instrument, which I can. I do not actually play. I do not actually play live keyboard. When I make my music, I build it up in pieces and speed up parts, slow down parts, and that's how I make my music. But so the response is very good. The way I've set it up, like I should actually go through all the sounds and make them velocity sensitive. Velocity is the velocity on this, because of the 64 SID chip, the way it works, I would have liked to make velocity work with volume, but because the volume control doesn't work well dynamically, it makes a lot of noise. The only thing I control with velocity is the filter frequency. So. If I hit it, oh, I'm in the wrong bank. did the first 16 or 32 sounds out of my 256. I played with them, optimizing them for velocity. But it would be nice to have all 256 optimized for velocity. It's just basically it's just changing the setting on the filters. You can't hear much difference here, but they're. Okay, like with this organ, when you hold it down really hard, there's a lot of highs in this, so you're not really hearing the way this sounds. Usually when you play the organ, what happens is it's a lot deeper when you hit it harder, and it's a little bit, has a little more tinny edge when you. So anyways, so I had just at the last minute, just in the last 2 weeks, I found out that it worked great with this keyboard, and I got all the bugs out of my K1, my Kawai K1 as well. This is a mini microchord, but my old K3, Kawai K3, uses something different called running status. And without getting into all of the technicalities of it, the bottom line is I had to scurry in the last 2 weeks, you know, while manufacturing the boxes for this. I had to scurry around and figure out how to program this thing for running status because the logic is way different. Regular MIDI runs with 3 bytes, and running statics, as soon as the first note comes in too quick, it just takes 2 bytes at a time instead of 3. And this was, my software was looking for 3 bytes, and 2 were coming in, and it was just the bottom line is the way the Kawai originally worked was I would play something slow and it was fine, but as soon as I started playing quickly, it would miss a whole bunch of notes. So the running status has been fixed. So, and in fact, I was looking online about running status. From what I read, Apple has a problem because a lot of people that have certain keyboards that have running status, they're not being supported. I heard that some of the Apple software does not support running status. So, like my old K3, and one of my customers is out in California. He has a K3 exactly like me. So that was another reason why I made sure that I got running status working for him. So anyways, how many here have already seen Fastfingers before? Is there anybody that has anybody not seen Fastfingers before? Well, there are. Always out there. So there's the 256 sounds in here, and the sequencer is nice to play with. Like I said the last time when I was here, I made it so that the sequencers, instead of being one 256 note sequencer, I split it up into 16 note sequencers. So on the fly you can pull up any one of 16 sequencers that are 16 notes, up to 16 notes long. And when you record your own sequencer, you tag it at the end of the sequence. So then it knows that's the end of the sequence. So you can make 4-note sequences, 8-note sequences, 12-note sequences. If you don't tag it the next note, and you start in the 0 bank for the sequencer, it will go into the next bank. So you could have a 31-note sequence. You could have with 16 and 8, 24-note sequence, because you wouldn't put an end tag until you. So what would happen? So when you're hitting the first key, you would get the whole 24-note sequence playing when you're playing on here. When you hit the second key, you would get the second part of the sequence because it indexes the way the index is set up for the next 16. Next That sound reminds me of Dark Side of the Moon. Dark Side of the Moon type of thing. Oh yeah, and the way I set it up, I don't have velocity on each individual note in the sequence. And I'm deciding whether I want to do that. Right now the way it is when you initiate a sequence with sequencer, it will play it with the velocity for that whole sequence. So if it's okay, so if I hit it lightly, now if I hit it harder, you're not hearing it. I wonder if this computer's filtering out the velocity. No, it's not, because I was already... Okay, so anyways, so the people that use that kind of stuff are DJs. They play these long-running sequences, and they get people up dancing, and they play with filtering at the same time, turning it up and down while these sequences are going, and they keep people up on the dance floor for 20 minutes for one song, and all it is a bunch of flurry of notes. And people just dance to that, and after 20 minutes they're in a trance. You know, and they're and they like it, and that's the kind of stuff, Get a nice solid beat with that, and that's what you get. Alright, so that was the first part of the demo. I wanted to show you some of Fastfingers. And is anybody here really honestly interested in learning any assembly language? There's one right back there. You want to learn some. Okay. I know everybody likes lots of media sound. Well, maybe I could show you some of the source code and for Fastfingers, and explain to you a little bit about it and how it works. Now, I got several iterations of the software because this thing originally started back in '82. I was working with the Pia synthesizer and my TRS-80 Model 1, and I wanted something that was encapsulated in one product, not with a bunch of garbage hooked on it. And so I came up with my friend was watching what I was doing with all these modules and patch cords, and my friend says, Danny, he said, there's something new out, I think you should see it. It's $895. It's called the Commodore 64. So I went to his house, I sat there, and he showed me, oh yeah, it's got this, it's got that, it's got a SID chip, it's got all these sounds. Look at these sounds. And I started writing this program. I had no user interface at all for it. Let's see here. I think you've all seen the user interface. I think you've all seen the user interface before. Oh, right now it's blank because it blanks out for MIDI. And all you have to do to get out of MIDI, before I used to have a button to switch from one keyboard to the other. Now you don't have to do that now. You just, as soon as you start playing on a MIDI device, it detects MIDI. It says, hey, there's a MIDI keyboard. Let's go to MIDI mode, blank out the screen. So you don't have a screen to look at, but you get to know where if you work with this all the time, you get to know where all these controls are. And basically, that's telling me the sequencer is on right now. So all I have to do is shut it off. And where was I going with this? So, okay, so I wanted to show you some source code. I need to get back. Yeah, okay, just quickly for the few that haven't seen the program before. There's a bank screen. If you look up there, those numbers tell you exactly where everything is. So in other words, if you hit the left arrow at the top, you're going to get the first note out of the bank, out of that bank. But there's 16 banks. Okay? And Q is various, there are various things. That's the main user bank that you run with your favorite 16 sounds. And then there's bass, wind, organs, drums, etc., etc. So in other words, if you want a sorted synth, or let's say you want they're not great piano sounds, they're cheesy piano sounds, but if that's what you like, you'd hit F5 while this key is down. This is a control key. You hit F5 for piano. And then you would hit one of the top keys to select which piano sound you want. So let's say I'll just hit 6 for random, and for a random thing to try it. And then there's A, which is put, or the up arrow, which is get. You hit that, and then that's the sound. It's kind of a cheesy piano sound. Oh, MIDI's not coming back. Kind of oh, I turned off Cubase, so I'd have to go directly into the keyboard, directly into the interface. I don't know. Yes. Yeah, I turned off Cubase, so there's no Cubase. I was passing through Cubase in order to play. I turned Cubase off, so it's not running. So I have to go directly into the interface. I think the velocity works a little better now without going through Cubase. I think Cubase may have been causing some latency or something. Anyways, I'm going to show you some source code. I've done this before. I've showed some source code. So I've done this this has been done over a long period of time. And so what I've decided to do is I have source code every month. You know, I re-update the source code probably 20 times in a month, but I'm trying to keep all the old source codes. So here's September 2016. And I'm going to switch over to this. Now, if you're writing, I use PAL, okay, the original PAL by Brad Templeton. I have the little blue book. That's the program I program with. I've seen there's a couple others. PAL, I think it's free now. But when I wrote a letter to Brad and I told him, I said, I was holding up the original in my hand. And I said, no, I'm not using the copy, Brad. I got the original that I've been using for the past 35 years. So, you know, so just to let him know when I wrote to him. But I like PAL. So, and I don't know if Brad has any objection to you getting a copy of PAL, but when you're working with PAL, it's like working with BASIC. You have line numbers. You make things, and you can also get power. There's power and there's PAL. And power will allow you to do renumbering, which is good because sometimes you're writing code and maybe you've made the numbers too tight, like 1, 2, 3, 4, 5. You get to the end of line 1 and you want to put something in line 2, or between line 1 and line 2, and what do? So you got to have a quick way of renumbering everything with 10. You know, right now everything I have is with line numbers of 1. It's a pain, but I've done that recently, and what I'm usually ending up doing is just using colons to separate code. So I try to cram 3 or 4 things on the line. But the proper way to do it is go back and use power and renumber everything every once in a while so that you have space in between your lines to write code. So I use PAL. Okay, so the first thing in an assembler is you have to designate all of your variables have to be designated. That's at the very top of the code in any machine language program. So I used to have a distortion table. I've taken that out. There's no more distortion. The distortion has been taken over with a velocity flipping thing, so that the velocity, if you don't like the way the velocity triggers the key, now you will be able to change the way the velocity affects the filtering. So I don't have distortion in there anymore. I played too much, fooled around with it for too long. You can get distortion without using distortion on Fastfingers. So, and I have other things called like temporary. Temporary is just, these are 0-page routines. That's at 5. So it's in the, I'm stepping on all basic and everything. Once you run Fastfingers, you cannot get into basic or anything because Fastfingers steps on everything. Yeah, so temporary is at 0005 in memory. That's a temporary storing spot I use to store things. I have temporary 1, temporary 2, temporary 3, temporary 4. MIDI on is another variable that tells the computer, it says, is MIDI on or MIDI off? As soon as you hit that key and it sees MIDI, as soon as you do that, MIDI on is triggered, it's 1 instead of 0. The way the program runs after that is based on that. It'll skip parts of the program and the thing about machine language you have to realize is it's so fast. You can run, you can load, like the screens come up, you see how instantly I can flip from one screen to another. When you turn on your new Windows machine today, they're not as bad as they were like the last generation, or maybe with Windows. You can actually see the icons going on the screen. Imagine this is 30 years ago. It has less memory to address, but the issue is it runs very fast with these commands. And when I get, so that's the first basic thing I want to get past. That is you have to put all your variables in there. Okay. There's a flange table. There's a phase shifter table. Then I have a table move. That's when I run that basic program. Everything when I run the basic program first, it takes it creates these pitch tables, throws them up in high memory, and then when I first run the program by hitting sys 81 times 256, it automatically goes to 5,000 and starts moving these things into the new locations. So like table flanges at 6114, and then later you can use that to record in that area of memory, because once it's once it's moved into the other part of memory, but I can't leave it in the, I won't get into that too deep, but that's the first step. You have to have, label your, and you know, there's things in your, if you ever have if you get a hold of a Commodore manual, it'll tell you, this is a SID address and these are different things in the SID. I'll show you the SID stuff in here. Some of these things I might not be using anymore, like CRA. I might not be using that. The timer for the timer counts down one clock cycle at a time, I think. And there's two timers, timer 1 and timer 2. This thing is holding the MIDI port so fast now that timer high is 0 and timer low is only 128. That's how fast this thing is holding the MIDI port right now, so that you have okay. So these are things that you'll find in your manual. You'll find these addresses in your programmer's manuals, C64 programmer's manual.
Are you referring to the Commodore 64 programmer reference
guide? Yes,
yeah.
Yes, that's right. The Commodore 64 programmer's reference guide. You'll find these addresses. So the thing is, you don't want to remember these addresses. So that's why you make these mnemonics or labels. Label for a timer low is that, and I don't have to think about this address anymore. So you make labels up when you start with machine language. You have to have labels. So we have all these labels. So like for the SID chip, there's a couple here. I have a thing called SID table. SID table is a mirror of the actual SID chip. You can't read and write from all the registers on the SID chip. Some are write registers, some are read registers. So this is a mirror of everything that goes in and out of the SID chip. It's in 0 page to make it quick. So I write something, if I do a filter routine, the filter, there are temporary filter areas, but then at the very end, I have to send it to the SID table at the same time as to the actual SID chip. And so there's a record in there so that if it has to reference and look in the SID table and see what something is set at, I have a mirror of everything that's in the SID chip. So that's how that works. But that's, I could have labeled every single device in the SID chip. Like, I do have another one listed here as a separate thing, envelope 3, because I use it so much, EMB3. It's the very last register of the SID chip, I think. And what it is it is the third envelope. And so that's basically what you do with the with how labels work. Now, after you get past the labels, I should say before you started with the label, that there's a few things up at the very top of this code too. My program has gotten so big over the years; it's in 2 pieces. It's in 2 pieces right now. This was just a list of programs, so this was called September List and September List B, which is the second part of the program. So I can't, in physical memory, I cannot put my source code in the 64 all at once. And that's another reason why one of the things I should be doing, I'm not doing, is putting a lot of comments on here. Because when I picked this up after almost 30 years, I picked this project back up and started working on it. I was totally in the dark. I had to refer to my instruction manual how to even run the program, even load the sound. It took me, I think, a couple hours to figure out how to load the sound. And I had this special trick where I had to hold down the Commodore control key while I was hitting the load button at the same time. And there's a reason for that. You don't want to load over top of something you're working on too easily, or right over top of something you've already created too easily. So that's the reason for making that so difficult. But anyways, So so you have to have these lines at the beginning of your code. That's not at the, that's at line 772, that's at the end. You have to, there's some things you can't see up here that you have to set up. I'd have to put this, let's see, maybe I'll get the, maybe I'll get them on here. I'll show you this for now, okay? There's a couple other things you have to set up. You can also get the PAL manual. There are things called opt. Opt means that the source code is being printed to paper. But I'm not using paper now. No more paper. I went through a page of 5,000 pages developing Fastfingers originally. A box of 5,000 pages of pen. It was insane. And don't do that anymore. This is a lot easier because this code is like it's 100 pages long right now. When it's stretched out, and you have one line of code for each line. It's over 100 pages. What were you going to say?
What do comments actually look like in this?
Well, comments, you usually use a semicolon. And when you use a semicolon, it says everything past that semicolon is a comment. So you could write a comment. You could say, this is to turn on filter.
Right.
Or this is to turn off filter. Or this is... and sometimes you could run 2 or 3 lines of comment if it's really detailed. I have some other comments. See, summary, see right here, there's comments right up here. Summary of modes 2 effects flags, because I don't remember them. I can't remember all this stuff, there's just too much of it. You know, vibrato, bit 0. Like I was doing things in order to use little memory as possible back then. I was not using a whole byte for some of my flags. I was splitting up a single byte into 8 pieces and using bit checking for each individual bit. You know, so bit 0 is a pulse bit, bit 1 is a glide bit, bit 2 is the thick, the effect I used to have called thick. The gain bit is bit 3, and bit 3 is actually the 4th bit. So bit 0 is actually the 1st bit, and bit 7 is actually the 8th bit. So when you're working with machine language. So this is so we have modes, and so then in modes 2, I have two different sets of flags. I have 16 flags set up, and so flags are a way of telling if is effect on, is an effect off. So when it's running through and it's playing the effects. It's running in this thing very quickly, and it says, is glide on, yes or no? Oh, it's on. Okay, well, let's do this. Oh, it's not on, let's do that. So it's like, let's do this or let's do that. And this all happens like in the 1,000th of a second. So let's go down into some actual code here. The heart of the Fastfingers is the effects. And originally the effects were one long effect thing, and what happened was when I started developing MIDI, I split up the effects in 6 pieces or 7 pieces. And let's see. So the nice thing about having this not on paper, now having it on a computer, is you can search for effect. And I'm using a free editor here. This is LibreOffice that I'm using to view. And you can also use OpenOffice to do this. Okay, so now you see I have these. Remember I told you the increment, the timer was set up to click only. It was very, very fast, but the effects are not as fast as the MIDI. The MIDI takes #1 priority now. So MIDI is first, effects are second. So what I have is a sub counter built into my effects called interrupt counter. So the interrupt counter is up here, INTCNTR, and what it does, it counts I think the number is 40 or 50. So 50 times after I pull the MIDI port, 50 times I say, okay, let's check now. No, let's initiate the effects. So then it runs through the effects. Now I used to have the reason I had them subdivided originally into JSR, select, JSR, and those are subroutines. A subroutine is when you jump to an area of memory and then you come back from that area of memory and go to the next spot. Rather than writing the same thing 100 times over, you write it as a subroutine. In BASIC, it's Go sub. Basic Go sub is like JSR in machine language. So the reason I have that split up, I came up with this idea that I would time each effect roughly and give it a certain amount of time. So I'd say decrement the interrupt counter. Oh, is it down to, is it 32 now? Yeah, is it down to 32? Oh, now it's time to execute select. So then it would execute select. And I said, now is it down? Now if it's down to 30, let's jump to the next effect. And the G effect stands for glide. I had a lot of trouble though when I split these up trying to get glide working. It was it works fine now. Trying to remember which key glide is without looking up there. I don't know if I can remember. Anyways, glide is working fine because right now I'm doing the other part of this. Glide is working fine now, and so yeah. Now something else now because I've disabled video, I have to change the effect timer. The interrupt counter is 40 when it's only 40. Let's see, how do I have that? It's running fast. It runs faster when the video is disabled. So the effect counter is 50 when the video is disabled. When video is enabled, so the reason for doing that is because if you switch from here to do your sequencer, all of a sudden you'd be doing your sequencer on here at one speed and then it would slow way down over here. So I have to make the effect counter differently. So it would, because also the sequencer itself is run by what's going on in the effect counter. So, and okay, so anyways, let me see if I can show you some commands here. Simple commands. Now, like in BASIC, if you wanted to say A equals 1, you would say A equals 1. In machine language, if you want to say A equals 1, or if you want to say a value equals 1, you have to first load it into the accumulator. So you load LDA MIDI data, okay? And then you have to, and then to put that, you're loading the accumulator with that value from that memory location. And then if you want to store it somewhere, you STA it, store it here. So load it and store it. That's how you load. So if you want to get a value like 1, see, because MIDI has just begun. This is the beginning of MIDI. Load the accumulator with 1, store it in MIDI on. So I just turned MIDI on. So load it with 1, store it in MIDI on. So that gives you a little idea of that. Do we have any idea of the time? I don't want to go over because I don't know.
2:45.
2:45, okay. So that's how that works. And then I was going to bring my book, I forgot. I have the original MOS book that I used when I started. I forgot to bring it with me. There's load commands, there's store commands. There's branch commands, okay? There's LSR is shift right. You take your bit pattern. If you know anything, you should learn a little bit about hexadecimal and binary before you start, because like the binary number for the number 255 is 8 ones. 1, 1, 1, 1, you know, eight ones in a row, that's the number 255. And there's, like I said, there's bit 0 and then there's bit 7 at the other end. It works the same as decimal. Decimal, the first digit is equal to 1, the second digit is equal to 10, the third digit is equal to 100. With binary, the first digit is equal to 1, the second digit is equal to 2, the third digit is equal to 4, the next digit is equal to 8, 16, 64, 128.
32. 16, 32.
Did I miss 32? You know what I mean. It doubles every time. So the number 20 would be, it would be 16 and 4. So it would be, bit 3 would be a 1, and bit 2 would be a 1, and that would then be 20. So then when you go to hexadecimal, it goes the opposite direction. Now instead of having 10, you have 16 things. So our 10 digits are not enough anymore. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to add A, B, C, D, E, and F. So F is 15. E is 14. D is 13. C is 12. B is 11, and A is 10. And so now when you multiply, so if a number is FF, it's actually 255. So it's 15 plus 240. That's what the F in the second digit is. So you need to know that when you're working with machine language. You should know that. Otherwise, it doesn't make any sense. Bits don't make any sense. None of it makes any sense. You should know hexadecimal and you should know binary. All right? So if I say LSR, if I want to multiply by 2, I would shift left. If I want to divide by 2, I shift right. Now sometimes when you shift right, you're shifting off, and there's a thing called a carry bit. Or the carry bit, I think, is when you shift left. So that's pretty well how that works. So what I did was when I LSR, I say BCC norm. That's another way. I used to do that by just ending with bit 1 and then looking for 0. Because at the very beginning, I never used any other flags except for the 0 flag when I was programming. I didn't ever use the carry flag. So this one day I got this novel idea. Let's just go through and see if I could kind of bite off of every one of these routines wherever I did that just by using branch on carry. That's branch on carry clear. That's what BCC stands for. Which means if you see that the carry flag is 0, go to that label, norm, somewhere NRM, where I have somewhere else in the program. Now there's another thing that's kind of interesting about this. You can only move with branching commands like this. You can only move in machine language 128 bytes up or 128 bytes down. I can't jump to the BC. If norm is way at the end of the program, I can't go there. If I want to get to norm with this check, I have to put another place in the middle and call it norm 2. And I jump to norm 2, and when I get to norm 2, I say jump, JMP, which is 3 bytes. The reason for it takes 3 bytes for a jump. For BCC or for any, these are called relative jumps. For BCC, it only takes 2 bytes. As you can see here, BCC norm is only 9006. Jump up here is 4C. 4C stands for jump. Jump to that address. That's a physical jump. Jump to EA, and they're backwards too. To make it more confusing, the address is not 7EA. The address is EA7E. So they run the addresses are backwards, and that is the way as you get along in it, you get to know that. Now the chip that's in my my MIDI interface, that uses a different language, and it has its own quirks and rules. But some of these basic things still hold. You still have to do bit checks. I do still bit checks and other things, but I don't want to confuse you there. This is 6502 we're concentrating on over here. So you have your branching commands, you have your jump commands, you have arithmetic commands, you have branch on carry clear, you have branch on carry set, BCS, you have branch on if it's equal, and the way you do, you want to check if you want to check a value of a register or a memory location, you would say SBC, which stands for subtract with carry, a certain value. So let's say I wanted to check if that a value is 30, I would say SBC 30, and then I would say BEQ, which is branch on equal. If I BEQ wherever, go branch on equal to wherever. And if it doesn't branch, it automatically jumps to the next command. It just goes to the next command automatically. It falls through. So that's the way this here works. Let me see if I have any other examples. Now this is something else I was looking at the other day. I was comparing the original Fastfingers code with this code. And I noticed that I have a thing called outskip based on the value of ENV3 here. Which means don't send a sound out, just make it quiet. Because I'm hearing a lot of noise. I'm trying to think, did I do something differently? Concentrating on the MIDI, did I forget about ENV3? ENV3, and by the way, it's the envelope. When the envelope hits 0, to make the chip as quiet as possible, I tell it, okay, we're at the end of our transient, at the end of our ADSR. Those are two different words. So now it's time to shut off the SID chip, because we don't want to hear this noise constantly. And I was wondering, is this the raster from the television? Is this actually the SID chip? What's making this noise? So I looked at this the other day. So just to try this the other day, I looked at my old Fastfingers code. I looked at this and I said, oh, I have a check for, I say LD load accumulator with ENV3 and BEQ outskip, skip it. How come it's not here? So I put it in. I thought it might make it quieter, didn't do anything. So I said, I don't need that there. I've already tested the program without it. So I pull it back out again. But I'm going to have to sit down with Fastfingers 1, Fastfingers 2, do A/B comparison, constantly listening to the sound, and see if there's somewhere, because that's the thing, we're trying to push the maximum amount out of this chip. Now, something else, this box here, originally I was telling people, this other chip down here is a DSP that I'm going to put in here, digital signal processor. Originally I'm going to use that to make sound. But I was also thinking, that would really be a cool way to modify the SID chip sounds. Because it goes into a digital signal processor. When I send it in, and then I can create my own ramps and cutoffs and shutoffs in that digital signal processor. But it adds cost to this. Right now this, my MIDI interface is going to be like $60. And when I put that digital signal processor in there and all that software and all that, I'm expecting 2 or 3 years of work at that at least. That's going to bring this up to $100. But there's going to still be this one available for $60. But the bottom line is this. I could use that not only for making sound, but I could also use it for modifying C64 sounds to make them sound better. A kid came to me yesterday. He asked me, he says, do you have digital delay on this? I said, because I had all these effects. No, I don't have digital delay. But with this DSP, I could have digital delay. Because it would be, because this is this digital the signal processor is a 16-bit processor. It's pretty decent. It's way cleaner sounding than the SID chip. And the SID chip is somewhere around 42 dB signal to noise ratio, and this theoretically is 96 dB signal to noise. That's providing I put the proper filtering on this board and do things proper capacitors, proper things. So, I guess I can't say too much more. This is kind of like a primer. I mean, machine language, I could talk to you for a month on machine language, you know, but just gives you just some ideas. It's not as scary as it sounds, because I'm going to tell you honestly, people are working with high-level languages such as C and those languages. What I don't like about them, there's massive, everybody's got a different open window command, and they have a whole bunch of different things, different ways of running that one command. If you want to open a window on here, you write your own code. You start from scratch, you write your own code, you work with those 100 commands that you have. You only have 100 of them. And the first thing you do is clear the screen, and it's a real simple thing. You say load the accumulator, I think it's with either 255 or a 0. I'm not sure. I think 0 is black. 255 I think might be white. And then you store it at 0400, X. And then it's another register. There's accumulator, there's X register, and Y register. And then you say increment X, and then go to the top. That would take 1/4 of the screen and do it. And then you do that 4 times, and the whole screen, and instead of flash, you see the screen turn white. Clear screen is like that. So that's the difference. Like if you were going to use peaks and pokes in BASIC to clear the screen, it would take, you'd probably see the screen, but they're pretty quick, but it wouldn't be like that. You know, like when I run the program, you can see things. Okay. So that gives you an idea of machine language, and I think that's about all you can take of this for today. So I hope everybody enjoyed what I showed. And like I said, if anybody wants one of these, they're $59.95 technically. Okay. And if there is any problem with the 64 software, I will. Anybody who got it today will, of course, get updates, and I'll send you the floppy in the mail to fix any issues, if there's real issues. I have my friend in California, and he lets me know if there's any issues. And I had a bug in Fastfingers 1, and he found a bug, and I fixed it, and I sent him out another copy. So that's, you know, okay, I think that'll be enough. I think that's enough.